Okay, adding and subtracting radicals. So this one is not bad, but it can be very, very sneaky, I'll tell you what. In order to add two radicals together, the radicands need to be the same. So whatever's in the radical needs to be the same. Also, the indexes have to be the same. And if they are, then you just combine like terms. And what's in the radical stays the same. So here I have 3 of the 4th roots of 11pq. And here I have -7 of the 4th roots of 11pq. Notice the index, the root number is the same for both of them. Both of them have 11pq as the radicand. So we're just going to combine like terms. 3 plus -7 equals -4 times the 4th root of 11pq. There you have it. That's it, pretty easy. But I told you, they can get sneaky. So I'm gonna erase this one. And we'll try this one here. Let's do the square root of 98x cubed y plus 3x times the square root of 32xy. So initially it looks like, well, the index is the same. They're both square roots. But initially it looks like what's in the radical is not the same, because they have to be exactly the same. 98 is not the same as 32. X cubed is not the same as x. But here's why it's sneaky. You gotta simplify them first and see then if you can add them. Let's break this one down and see what it simplifies to. So 98 would break down to 49 and 2 is one way to do it. Then I would have 7 and 7. And I would have x to the 3rd. So I definitely can pull out a pair of 7s. I can definitely pull out an x. And then I'm left with this loner 2. That's gonna stay in. I'm left with an x. And I'm left with a y also. Okay, so I have 7x times the square root of 2xy. Now, let's break this one down. I can go 16 and 2, and I can go 4 and 4. So I have a pair of 4s that can come out, and I'd be left with a 2 and a y on the inside. Now, if this 4 comes out with that 3x to be 12x, it'd be plus 12x, and inside, I have a square root of, this 2 is left over, x is left over, and the y. So look, even though they didn't really look the same initially, when we simplified them, both of these terms have 2xy on the inside. So I can combine the 7x and the 12x to give me 19x times the square root of 2xy. Okay? Now, this next one, I feel like is a little bit more challenging. I'm gonna steal this next one from the book. It's a good problem, but it's also sneaky. So this one is going to be the cubed root of 64 m to the 4th n to the 5th minus the cubed root of -27 m to the 10th n to the 14th. Okay? Now, initially it looks like, well, we can't really subtract them, right? But as you can guess from the last example, we've got to try to simplify it first. So the cubed root, be careful with this one. The cubed root of 64 is 4, so we can pull out a 4. I can also pull out an m, leaving 2 m's left in. I'm sorry, one m left over. I can also pull out an n, leaving two n's left in. So what's left? Well, everything came out from that 64 to give me this 4, because the cube root of 64 is 4. I pulled out 3 of the 4 m's, so I'm left with an m. I pulled out 3 of the 5 n's, so I'm left inside with an n squared. So I'm left with mn squared on the inside, and on the outside I've got 4mn. Now, careful here. The cubed root, can I do the cubed root of negative 27? I can, because it's an odd root. So the cubed root of negative 27 is negative 3. I'm going to pull out a negative 3, so I have minus negative 3. What's that really going to be? Yeah, you guessed it. It's going to be plus 3. So instead of minus negative 3, I'm going to call it plus 3. And let's see, can I pull out an m? How many trios of m's am I going to have? Well, I have 10 m's being multiplied all together. That's going to give me 3 trios. So I can pull out an m to the third, and I have 14 n's being multiplied. That's a lot of n's. So there's 14 of them. Well, 12 is divisible by 3. So I could pull out n to the fourth, and that would take care of 12 of the 14 n's. Now, on the inside, I have nothing left from the negative 27. I pulled out 9 of the 10 m's to leave me with just an m, and I pulled out 12 of the 14 n's to leave me with an n squared. And look, the radicand, or what's in the radical, is exactly the same for both of them. So I can combine them. But this time, what's on the outside really isn't a like term. Here I have m cubed n to the fourth. Here I have mn. So I can't really combine those. But since these are the same, we want to write it like as if we could combine them. So I would add these two if I could. So I'm going to say 4mn plus 3m cubed n to the fourth, and then times the cubed root of mn squared. By writing it like this, basically what you're saying is that, you know, we want to combine this and this because their radicands are the same, but since 4mn plus 3n cubed n to the 3m cubed n to the fourth are not like terms, this is the best we can do as far as combining them. I don't know what you think. I feel like there's going to be mixed emotions on that one. Thank you for all these sections of R7. Can you believe it? We got more of them, but that's going to be it for today. Thank you so much.